Okay, we're going to look at section 5.5, which is nonlinear systems of equations. Now, in order to be a nonlinear system of equations, all that means is that one of the equations, one or more of the equations, is not a line. Okay, so it may be a quadratic, it could be two quadratics, it could be a line and a quadratic, a line and a circle. It's anything where one of the equations is not just a straight linear function. Okay, so for example, we've got x squared minus y equals 4 and x plus y equals negative 2. The first one, because the x squared is not a line, okay, it's actually going to be a parabola. Okay, now with the way that this system is set up, okay, currently, it works well with elimination, because if I go ahead and add these two together, okay, now I can't do x squared plus x, okay, and have a single term, but I can do x squared plus x, the y's will go away, equals, and that's going to be 2. Now, I can bring this back across, and I can solve. So I've got x plus 2, x minus 1. Okay. So then x plus 2 equals 0, x minus 1 equals 0, x is negative 2, and x is 1. Now, with this, we do have two separate x's, so that means we're going to have two separate y's that are also going to go with this. Now, I'm going to plug this into the second one. So I have negative 2 plus y equals negative 2. I'm going to add the negative 2 back over, and I get y equals 0. So I have the ordered pair negative 2, 0. That is one of my solutions. So that's all in one slide. Okay, and then I'm going to have 1 plus y equals negative 2. I'm going to subtract the 1 and get negative 3. So now I have 1 comma negative 3. And these are the solutions to that. Okay, now if we were looking at something graphically for this, okay, and I'm going to turn my board over here so I have a lovely grid space. Okay, that first equation, okay, which was x squared minus y equals 4, would have translated over to y equals x squared minus 4. So graphically, here, okay, just kind of creating a nice, pretty there. And then our second one, which was x plus y equals negative 2, would have been negative x minus 2 okay. And we see that sure enough, we have the ordered pairs negative 2, 0, and 1, negative 3 as our ordered pairs for where that works. Okay, so we have that graphically verifies what we just had. Now, please note that when we have this happen, we now have some different options available to us that we did not have before when we were doing the linear systems of stuff. Okay, so what we can have happen here is we can still have no solution. Okay, so if we had just looking at a parabola and a line, just looking at those two, I can have that the parabola and the line don't touch each other at all. I can have that the parabola and the line touch each other at one spot, or I can have, like we saw in that last one, the parabola and the line touch each other at two locations. Okay, So when you have a parabola with a line, you've got kind of three options that could show up, okay? So now, looking at another example, okay, I've got x squared plus y squared equals 4, 2x squared minus y squared equals 8. Now, again, because of the fact that I've got the positive x squared, negative x squared, this looks really good for elimination. So now I do have x squared and x squared, so it's going to be 3x squared. Those are going to cancel off. Leaves me 12. Solving, I'll divide by 3. So I've got x squared equals 4. Square root on both sides. Again, we brought in the square root, so we're going to bring in plus and minus. So now I'm going to look at when x is 2. Okay, and I'm just going to plug that into the top one. I have 2 squared plus y squared equals 4. So I've got 4 plus y squared equals 4. Subtracting, I get y squared equals 0. Square root is 0. Now, normally, okay, we would do plus and minus, but there's no such thing as plus and minus 0. So we just have, and I'm going to have the ordered pair 2, 0. Okay. Now, dealing with the other, okay, when x was negative 2, okay, okay. So we've got something that looks like that. Okay. Now this one is the first equation, x squared plus y squared equals 0 or equals 4. That's a circle. Okay. So now looking at another one. Okay. Now, what I'm going to do for this one is I'm going to multiply this second line by -1. So top line again. And I'm going to get my x squareds go away. These go away. So I have 4xy equals 16. Okay. Now, what we're going to do here is we're going to solve, okay, because guys, here's the deal. In this one, I've got x squareds, y squareds. I've also got this xy combo. So I need to make a letter go away out of this somehow, okay? So what I'm going to do is I'm going to solve this equation for y. So I'm going to divide by 4x, which is going to give me 4 over x, okay? So now what we're going to do is I'm going to replace that. And I'm going to go back up to this simpler equation. So now I have x squared minus x times 4 over x plus 4 over x squared equals 6. Okay. Now, cleaning this up, I've got x squared. This times x divided by x is going to go away, so it's going to give me a 4 plus 16 over x squared equals 6. Okay. Now I'm going to drag the 6 back across. Now, the next thing we don't like this x squared down here on the bottom. So I'm going to multiply the whole thing by an x squared to make that go away. So I have x to the 4th plus 16 minus 10x squared equals 0. Okay, and this problem is a little bit more involved. okay, because they did give us that combination of letterings, okay? So I'm going to do a little bit of rewrite over here. So we've got x to the fourth minus 10x squared plus 16 equals 0. Now, I'm going to do a replacement. We've done replacements before. I'm going to let u be x squared, which means u squared is x to the fourth. So this is now u squared minus 10u plus 16 equals 0. That'll factor to u minus 8, u minus 2. So we've got u minus 8 equals 0, u minus 2 equals 0, u is 8, u is 2, and now we'll back solve. Oh, should be a 2, sorry. Okay. Okay, so we've got that's plus and minus 2 square roots of 2. Okay, now going back to when we said y. 4 over, now I'm going to carry the plus minus when I get down here to the end of this problem. 2 square roots of 2. Now, rationalize, first off, I can go over 2 square roots of 2, which when you rationalize is going to be 2 square roots of 2 over 2, which is just going to be square root of 2. And then over here, I'm going to have 4 over square root of 2, which is going to go to 4 square roots of 2 over 2, which will go to 2 square roots of 2. Now, bringing this back up, okay? We have 2 square roots of 2, comma, square root of 2. We have negative 2 square roots of 2, negative square roots of 2. And again, where that is coming from, I said I had a plus minus here. I worked the math and I got positive. If I had put negative in here, I would have carried a negative through the line. Okay, so I have those two answers. And then I also have when we got the answer square root of 2, which is going to be 2 square roots of 2 with that one, negative square roots of 2 with negative 2 square roots of 2. And again, guys, this problem is a little more involved because those equations were a little more involved, okay? We actually had to use a couple of different methods to do this with, okay? Now, sometimes it is helpful, okay, if you're doing some of these systems to graph what it is that you're looking at, okay? Sometimes it just makes a little bit more sense and it is helpful to do that, okay? So if we were going to look at the equations, x squared plus y squared equals 16, and absolute value of x plus y equals 4, okay? Now, first off, the top one, that is your format for a circle, okay? It has a radius of 4. Okay. Now, if I solve the other one, I get y equals negative absolute value of x plus 4. Now, guys, y'all have graphed absolute values. Y'all know that those are your V-shaped graphs. So it's up 4, and then it has a down 1 over 1 slope because it's a negative absolute value. Okay. So this one actually has 3 solutions. It's going to have this one over here at negative 4, 0. It's going to have this one up at the top at 0, 4. And it's going to have this one over here at 4, 0. Okay. So sometimes it's easier, like I said, sometimes it's easier to graph them, especially if they are familiar. If they are familiar equations that are easily graphed, okay, they come out a little bit easier. Now, okay, I do know that the top one is a circle, guys. The second one is not a circle. It is not x squared, y squared, okay, without the plain numbers in the front. So this is actually more of an ellipse shape, okay, which we did not cover, okay. This one also has a radius of the square root of 5, which is going to be kind of ugly. So I'm going to do this in our traditional elimination. This top one by -3 to get rid of the y's. It's going to give me x squared. It's -4. Okay, now you can get complex answers. Okay, now again, I'm going to plug this back in. So I'm going to do 2i squared plus y squared equals 5. And then I'm also going to be doing -2i squared plus y squared equals 5. Okay, so this is going to be 4i squared. Remember that I squared is -1. It's going to be -4 plus y squared equals 5. Add the 4. Y squared is 9. So y is square root of that is going to be plus and minus 3. Solving over here, this is 4i squared plus y squared equals 5. Again, 4i squared turns into -1. So I have, for my answers, I have 2i 3, 2i -3. That came from this first set over here. And then from this second pairing or second plug-in, I have -2i 3 and -2i -3. Okay, so there are our solutions for that. Now, looking at an application for this. So an application problem. Okay, we have a box with an open top. It has a square base. Okay. Okay, so this is a square base and a height of y. Okay, they tell us that the volume of the box is 75 inches cubed and the surface area is 85 square inches. They want us to find the dimensions of the box. Now, first off, volume is length times width times height. So volume is going to be x times y. It's going to be x squared y, and that's going to equal 75. Now, surface area, okay, we're going to have each of the sides of the box is going to be x by y. So it's going to be xy 4 times. Okay, it is a full box, y'all. So that's going to be 4x, the bottom, which is x squared. And we know that 4xy plus x squared is going to be 85. Okay, now what I'm going to do for this one is I'm going to solve this equation for y, kind of like what we saw in that one that was kind of involved. So y is 75 divided by x squared. And now I'm going to replace it. So I've got 4x times 75 over x squared plus x squared equals 85. Now, x and then divide by x squared is going to leave me, and then 4 times 75. This is going to be 300 over x plus x squared equals 85. Okay. Now, I'm going to multiply through by an x to clear this up. So I've got 300 plus x cubed equals 85x. Okay. And I'm going to pull everything to the same side. So x cubed minus 85x plus 300 equals 0. Now, guys, for this one, okay, you're going to need to go to a calculator, okay, plug this in, and because we're setting it equal to 0, you can either find the x-intercepts, or you can do the second, you can plug in that second equation. Okay, and what Mike is coming up with, I'll bring this over, okay, is I'm seeing 2 intersection points that are right here, okay? So, trying to see if there's a third one. The third one is over in the negatives, okay? So we can't have negative values, okay? So we don't need to worry about that one. Okay, and when I do the addition, one of the points is 5.64. The other point that I get is 5. Okay, now, when we plug those back in, I'm going to go right back up here to that 75 over x squared. Okay, I'm going to start with the easy one. So if x is 5, y is 75 over 5 squared. It's going to be 75 over 25, which is going to be 3. So the box is 5 by 5 by 3. Okay, now, if we do that x is that 5.64 number, we're going to have that y is 75 over 5.64 squared. Okay, and we get that y is going to be 2.36. So then my dimensions would be 5.64 by 5.64 by 2.36, okay? So we've got kind of 2 options there. Now, they would probably opt for the cleaner values at 5, 5, and 3, but do know that there is a secondary option where it's a slightly larger box, base box, but a slightly shorter height, okay, when they bump up. So that is the end of section 5.5. I hope this